Singularity.
My name is Nicola, and you're watching Singularity FM, the place where we interview the future. If you guys enjoy this podcast, you can help me make it better in one of two ways. Number one is you can write a brief review on iTunes, or number two, go to interviewthefuture.com and simply make a donation. Today, for the second time, my guest will be Joscha Bach. Joscha is probably the best way to describe him, in my view, is to say he's a beautiful mind. And if you want a further explanation about who he is, I highly recommend you go check out our previous interview, which is absolutely fantastic. And people loved it so much that I really had to bring him along, even though I'd love to have a conversation with him, even if I wasn't recording it or even if it was not a podcast, just because he's such a rewarding interlocutor on any topic that I can possibly imagine. So without further ado, Joscha Bach, welcome back to Singularity FM, my friend.
Thank you, Nicola.
Joscha, it's been almost 4 years since our last conversation, and we kind of discussed it. We would have another one in a few months, but here we are, 4 years later. How have you been?
Well, relatively good considering. There was a pandemic in between to homeschool the kids. We live in California now, currently in the Bay Area. I'm working for Intel. I'm in a new team. We are discussing in this team the future of artificial intelligence and try to understand what comes after the present developments and how long that will take. So it's an exciting time to be in, and we are in the place where I feel it happens. It's basically weird when I think that at some point I realized as a young kid in Germany that artificial intelligence was going to happen one day. And I thought about how I could get into this and get closer to this. And now I feel that I'm very close to where all these developments are taking place.
You are indeed very close. You're in the kitchen in a way. So tell us a little more about, because last time you were kind of in this kind of, as you explained it, zero gravity academic position. And now suddenly you find yourself working at Intel. And of course, part of the topic of our conversation is, of course, artificial intelligence, how far we have come and how far we have to go, and what's the kind of potential timeline that we may get to get there. So tell us a little more about Intel, or the position you're working at, or how you got there, anything that you find relevant.
I thought that I wanted to spend a few years on the West Coast of the US to get ideas and interact with people and the communities here. And I was offered a position as research leader in a startup company and took this for a while. And then I was hired into a different position where I could do more of the things that I wanted to do at Intel. But it's in some sense, not very different from an academic research position. We have a team that doesn't feel very different from a team at MIT or so. It's not focused on building products, and it's not focused on dealing with customers. It's really a basic research unit that allows Intel to do some cognition. And that's why I was able to take this position. I'm quite grateful for the opportunity that I've got. But it's really an interesting time where different approaches are being tried around me, and people are working on different areas. I found myself within Intel in a relatively large research community that spans many countries, and got new contacts through it into neuromorphic hardware, and at the same time into developments of better transformers, which is one of the biggest topics right now in machine learning, and in the combination of a lot of methodologies.
Wow. Well, perhaps you can kind of enlighten us a little bit, because to be honest with you, and I'm sure you wouldn't be surprised by that, but Intel is not the first company one would think of when we think of AI. Intel might be the first company we think of when we think of microchips and CPUs, and maybe falling behind Moore's law in the last few years and having to reschedule their launches a few times in a row and all those things. So how would you qualify Intel's approach, or in other words, what makes Intel's approach towards building AI different or unique, or is it maybe it's just the same as anybody else's, deep learning and so on? Or
And I think that Intel is in an interesting position. Don't feel like making advertisement for my current employer, but with the start of the new CEO, Pat Gelsinger, Intel tried to reverse course in many ways. In the perspective of many outside observers, and I think also many inside observers, what had happened in Intel in the past was that they used their comfortable position as the world's leading semiconductor supplier to invest the profits into stock buybacks rather than R&D. And this means that Intel um, came late on a number of crucial developments. So NVIDIA and AMD are now having parts of its lunch. And Intel has realized this and has tried to turn it around. And this means that they also put considerably more resources into future leading research. And some of that, a lot of that is open-ended because we don't know what the future brings. So by putting a few $100 million into research, it's possible to secure future businesses that are worth many billions of dollars. And this is a thing that Intel can not afford not to do. Personally, I think that Intel should understand itself as an AI company that is building substrates for AI as its specialty, and it should maybe become more design-centric. And at the moment, I think there is a slight transition happening in this direction. And our own team, Emergent AI, is one of two major initiatives that have formed in the last year and consolidated. One is called Emergent AI, the other one is Social AI. Both of them are doing future leading research and basically explore a whole array of technologies that happen in a particular way. So Intel is not making a single bet on this is or that is going to happen, but rather it's looking at which things are going to be used, which things are working, which things will be working soon, and what is the hardware that we are going to have to build to support it in the future. So we are looking at what's going to happen in 3 years from now, 5 years from now, 10 years from now, and try to anticipate this by building various things that have to work now.
so overall, is Intel pursuing more the hardware foundation for AI that other people can build software for, or is it pursuing software research at the same time that can be built upon the hardware that they're designing for sure?
I think it's a little bit comparable to what happened at NVIDIA when they did the investments in StyleGAN. Right, this was an extremely interesting development where they hired some top researchers in the field to build generative adversarial neural networks that could generate faces. And this was one of the many efforts that NVIDIA has started internally to get themselves to understand the technology that they would need to build to support this. So in some sense, it's a way of dogfooding your own products to use it as a researcher. And at the same time, they found that the StyleGAN developments were useful for developing technology for NVIDIA, for instance, for video compression of faces and for video games and so on. And at the same time, this is something that Intel is seeing is happening. And we have some efforts that are directly focused on hardware, but the majority of the things that we do are pure software efforts, are pure open source, are purely about how can we serve the community in AI, in identifying things that are currently under-researched and into which we should put resources. So a lot of the work that we are doing as researchers is very self-directed and doesn't feel hardware-centric or product-focused.
Mm-hmm. Well, you're kind of in the kitchen of Intel now, so people wouldn't forgive me if I don't ask you about what's the consensus on the inside there. Is Moore's Law alive or dead? Because some people would observe that we have gotten probably, single or maybe high teens, like 15, 20% improvement generation over generation for the last maybe 7 or 8 years. And that's not even including perhaps the several delays that Intel has had to sort of implement or accept in that development. So What do you think? Is Moore's law alive and well or dead?
I don't really feel competent for making such a prediction. I know that there are people which say within Intel that it's our mission to keep Moore's law alive. I also see that there are some developments happening in alternate hardware that could make dramatic changes in the future if they work. But these are interesting bets. And I think what's probably going to happen is that we will have hardware that is specific for particular purposes, like inference for certain applications. And this makes it hard to compare things across the board. Because in some sense, the GPUs that we are building, seeing in the industry, are a lot faster than things happened in the past, but they require new programming paradigms. And
right.
So a direct comparison might not be possible. But also, I think that there is something like a limit in physics that is theoretically not close, but practically to get closer to that if you want to build conventional technology, if you want to build deterministic hardware, or don't want to change the architecture of the von Neumann computer, where you are increasingly approaching limits. But again, I'm not a hardware expert, so I'm not actually competent to have a deep opinion.
You haven't heard any of your colleagues making comments on that?
Yes, I do,
Because
but it's I'm unable to judge the entire space of that. So
right.
I feel that I would be on thin ice.
Right. Because just to share with you my own personal experience, I was buying my wife a new laptop. So her laptop was a Dell XPS and it was 6.5 years old. And I bought her, and it costed 2,000 years back in the day when we bought it. Now we bought a brand new Razer laptop, and it was $2,450. So let's say with inflation, this and that, let's be generous and let's say it's about the same 2,000 price range. I run a few benchmarks, and the best I could do was about a 60% improvement. And quite often the difference between her 6-year-old laptop was about only 40%. Now, if Moore's law were to be correct in the last 6 years, we would have had 2 on the power of 3. So we would have had to have an 8-fold improvement. But as I said, in the best case scenario, we've had about 60%. And that's consistent with AMD, by the way. AMD supposedly has been eating Intel's lunch, as you said, for the last 3 or 4 years with their Zen generation of CPUs. And they've been kind of announcing anywhere from 15 to 20, 25% increase generation over generation. And that's their own internal figures. So it's up for debate whether and how accurate these figures are. And in some cases, they may be overestimating the reality. In some cases, interestingly enough, they can be even a little bit underestimating. So that's all to say we have to accept it with a grain of salt. And overall, the conclusion between those two examples could be that perhaps, at least as far as CPUs are concerned, Moore's law is not doing that great, if at all.
Yeah, and I found that when you get a new Mac, there is a significant improvement at the moment. I think that Apple has hung the bar a lot higher for the industry, especially with respect to how much compute you get out of a certain wattage and cooling in your system, which is what's in many ways limiting what you can build into a laptop today. And I think most of the computers that we consider buying these days are laptops, which for me is a big change. I remember when desktop systems were mandatory for the kind of work that we were doing. And now the systems did shrink. And on the other hand, there is a limitation in what people can build into these machines. And this factor is subjectively shrinking. And the software rot that is happening in the operating systems that makes things more sluggish is not disappearing. So there is basically seems to be a rate at which the compute that we get into our systems, and I mean even 15% per generation or 20 or 30% is not too little if you go for a few generations, right? But our software gets slower at the same time. And it's an interesting situation that we have such a duopoly on the software front, for instance. I suspect that if we want to get a third operating system launched ever, which has been tried several times and didn't work, we never got a third desktop operating system that was worth using, despite the developments in Linux and so on. we probably have to move inside of Apple or Microsoft and destroy one of the existing operating systems from within. Maybe that's already happening. Maybe that's why they're getting so bad.
What about Linux? Many people love Linux as a third operating system. Cory Doctorow is a big supporter. He's been using Linux for at least 10 years.
I've been trying
straight
to
on.
use Linux from time to time, and I did not like user experience. Starting with fonts and white space, I basically didn't see a single desktop that was consistently designed and was not insulting. And I don't know why this hasn't happened in Linux, and I suspect it's because Linux does not have centralized oversight. There has been individual systems that try to change this a little bit, but there was no enforced style guide for the entire application suite. And for me, the inconsistent user experience is one of the issues why I don't think that Linux is up to par when I compare it to macOS.
That's very interesting because I feel exactly the same way. But Joscha, I had a few audience questions submitted to me today, and one of the consensus that we got is that perhaps we should try not to get too technical and stay at the bigger picture. So let me ask you with two kind of a personal side questions, even if you will, and they both come, or a few of those come from none other than Mark Twain, the good old wit from American humor. So Mark Twain wanted to know why building a zoo without right angles was important for your dad.
I think that my dad did not like or my father, the ways in which society was reining people into boxes. He didn't like the brutalism of the Soviet era architecture in Eastern Germany. And he did not like the rectangular ways in which people's lives were planned out in the late modernist era that was trying to structure the economy and culture of Eastern Germany and of many of the countries that we lived in. And he felt this subjecting people to this Taylorist approach in which our lives are planned by people who do not have to live these lives, but want to simplify them, is especially cruel if we do this to animals, which have no beef in this. And he felt that if we want to put animals that we are taking out of the natural habitat into our cities, we should not subject them to the same inhuman and alienating experience that humans had. And of course, a lot of that is also born out of the time in which he studied and grew up, which was the late 60s.
Mm-hmm, mm-hmm. And do you feel that that kind of approach has rubbed on you? Because to me, it looks like it might have rubbed very well on you. You tried to kind of round up the angles or have your own vision about whether or if there should be angles and what should they be in what you do.
Yes.
Is that fair to say?
It's true. I think that we, as children, were keenly aware of the need to impose our own aesthetic on our life and our surroundings if we want to live a life that is worth living. And in the place that we grew up, which was quite isolated and remote, this was in some sense a different universe. And we looked out into the universe where the people lived, and the people lived in ways that I found disagreeable, and they were obviously disagreeable. I did not see why they would waste their lives like this, producing things that eventually go into landfill and that are very transitionary and not intrinsically useful. A society that rarely questions what it's good for, and that is not giving people that live in it largely a very good deal. And I thought that there is much, much more choice than people are aware that they can have. And our parents were more of the kind that told us, if it doesn't matter whether you are a shepherd or a painter or whatever you do, but if you don't work hard to do exactly what you want to do, you might end up in a factory or an office, which for my parents was in some sense the projection of a failed life.
The worst punishment possible.
It was not the worst punishment possibly, of course. And if we were going for such a thing, and I do work in an office, although it's a home office, that I can staff myself, and on projects that I can pick myself, which I think is quite luxurious for most people. I find that I largely still agree with their judgment. It's difficult for me to work on things that I don't think are intrinsically important.
Fantastic. And so I introduced you today for those of our viewers and listeners who may not have seen our first interview when we went a lot deeper into your background as a beautiful mind. That's always fun to have a conversation with. But if you were to introduce your own self in a sentence or at the most or in a word or two, how would you do that? Who is Joscha Bach?
This depends on the context entirely. I'm a human being that is trying to understand the world. And I think this is true for all of us at some level. And some of us forget it. They basically stop the exploration or limit it after childhood, and they specialize much more. And of course, I also have to do this, especially once you have children. Your role in life changes dramatically. But I still have this childlike need to explore and to observe things. And the areas that I studied in and tried to understand were always in a way philosophical and at the same time technical, because I thought that we need to be narrow and strict and honest with ourselves if we want to understand what's actually going on. And I found that I did not really fit well into the institutions of academia in doing that. And I often had the opportunity to work in there, and it was a lot of fun, especially teaching and working with students and exploring with them together. At the same time, the institutions are serving different purposes than they did 50 years ago.
Wow. So let me ask you this then as a follow-up. If you were to be fortunate enough to have a meeting with God, or an almighty godlike artificial superintelligence, what kind of questions would you ask of them?
I found that there are a number of the deepest questions that I had when I was born, like what is the meaning of life, or not when I was born, but when I grew up or throughout my life. How does consciousness work? What is the future destiny of humanity? How is it like to be another person? What is it like to be loved and connected? How does love work? How do we get relationships to work? How do we get a relationship with ourselves to work, and so on? All these different questions were things that I felt I could answer in the course of my life. I find that even questions like why is there something rather than nothing can be answered. And
do you feel you're closer to getting the answer for those questions today than last time we talked together 4 years ago?
I constantly get answers by asking questions and thinking about them and discussing them with other people and picking up ideas and combining them and developing them. Yeah.
So which question do you feel you're closest to the answer to today?
Oh, that's a difficult question because I never know how far I am from the answer when I don't have the answer yet, because you don't know what the details are. Otherwise, you'd be directly at the answer. But for instance, one of the things that really puzzled me a few years ago was the question why there is something rather than nothing at all. Why is there existence? I thought that the question, what is consciousness? How is it possible that there is conscious experience? Is not that hard to answer once you realize that you exist in a dream, and how machines that can have dreams could work, and how you can entangle them with the universe around them, and how models work in general, and so on. Then you get into technical details. And I don't think that the algorithms that we currently use to let our machines dreams are optimal, but they're already starting to become quite good models of what dreams are. So a system that is able to discover an agent that it runs on in the world and develops a first-person perspective as a result, because it tries to model everything, including that agent that it runs on, and including the attentive observer, that seems to be almost within reach, and it's going to happen quite soon. But the question of why there's something rather than nothing was pretty shocking to me.
Wow. There's so much there that I want to unpack. Everything is so interesting. Okay. Well, let's just follow that line, and then we'll go back to the AI. But so let's say one way or another, you have all of those questions answered. Then what? What would that mean to you as an individual, as an identity? Who is Joscha Bach going to be after all of your questions have been answered?
I don't think that's very important. It's this is like you play music and you try to compose and you ask yourself, who am I going to be when I'm done with all the compositions? So basically, as long as I'm curious, I'm going to explore, and there will always be more to explore, more details to understand about psychology, about sociality, about how to raise children, about how to not despair, how to build sustainable interactions with other people and with the world around us. So there's so much to do. This is not the issue. So as long as I don't get jaded or bored or lose all my energy, I probably will go on like this.
Yeah, so in other words, you are enjoying the journey, just like in dance. The point of dancing is not to get from one point of the floor to another, or to do so in the fastest way possible. Just like when you're playing music, the point is not to play the fastest way possible and get to the end of the musical performance. The point is to be present there in the moment and to enjoy that moment and to be there for it, to experience it. So you're not so much like obsessed with the final destination, but it's more about the process.
I think that as you observe yourself for a while, you notice that this is always the case. Right? Whenever you have a goal, this goal is instrumental to something else. And ultimately, you can discover how you are driven by some abstract need for transcendence and for a search for meaning or for integration of yourself with the world or for the transcendence of what you are. So you realize that at some point you make a switch from being a particular person to being a vessel for a person that you can create as needed. And your identity changes when you do that.
Mm-hmm. Yeah. And of course, the kind of questions that we ask, the reason why I'm so curious always about questions is because questions are like flashlights, you know? They set the field of vision for us of what's possible for us to observe, what's possible of us to consider, and even the realm of the possible answers is being preset by the flashlight of those questions in a way. So that's why I find it so curious to ask what's the questions that people are going after.
Yeah, for me, it's basically all the basic questions. The questions that I don't see an obvious answer, or things that are at hand and that need to be resolved.
At the same time, you're very optimistic that you're making progress, which is very interesting observation. And at the same time, now we can maybe narrow it and go back to the AI. You think, it seems to me, you made like a couple of minutes ago a very kind of an optimistic proclamation that we are not only closer than before, but we are very close indeed, perhaps. Is that correct of me to interpret?
It's hard for me to say how close we actually are. What we currently see in this year is a number of milestones that produce things that surprise many of the experts in the field.
Give us some of those examples of milestones.
I think the most obvious one that people are looking at right now is OpenAI's development of DALL-E 2, which is taking the 2017 transformer algorithm in the realm of images and combines it with a few new discoveries like diffusion models. And there is a deeper understanding of how we represent meaning. The idea here is that there is a multidimensional space in which we can represent all meanings. And this high-dimensional space can be reconstructed in a model by sorting all the things that you come across with as patterns in data by similarity. And this is an unsupervised mechanism that is just operating on patterns in data by itself. And that itself is sufficient to lead to a convergence of spaces of meaning in different modalities. And you find that the space that emerges when you are just doing analysis of text, like happen in GPT-3 and BERT and the other transformer models of text, by feeding them basically all of the text that is available by now, allows us to make a model that is in its sense just an autocomplete mechanism for text, which says, giving this text that you've seen before, the last 3 pages, how is that text going to continue? This is sufficient to solve many, many problems that existed before in AI and that couldn't be solved en passant, like questions of how to summarize text efficiently and so on, or how to generate new text that is conforming to a specification. And there are difficulties with this approach. For instance, how do we get this model to understand the context that it's currently in? How is 2 pages of text really sufficient to set the context for any type of problem? And how can we make this real time at any time? But this text space of meanings is almost congruent to a visual grammar that we get by analyzing pictures from the internet. So DALL-E 2 has been built by organizing 800 million images together with captions, and then combining the images with captions or with different captions, which is called contrastive learning, and thereby creating an alignment between text and images. And this was a huge computational effort that was required to get this to work, but it's largely simple algorithms that are easy to understand, as in takes only a few months to really understand them in depth and make progress on them. And just scale this up. And the scaling hypothesis that the existing set of algorithms is sufficient with a few tweaks, but with end-to-end training rather than hand-tinkering new solutions. That is a very powerful thing that has emerged in the last few years. And it's still unclear if the scaling hypothesis itself, that is, if you can get to systems that have generality that achieves and surpasses human universality and generality just by scaling up, it's not clear if that is sufficient. I think that in order to...
because that was my question,
To get there, we will need to build systems that are directly entangled with the world, that have real-time capability, that are tracking the universe that the system is entangled with. And they also need to be continuously learning, because the world that we are entangled with is an open world. It's one where new objects appear that we cannot always predict from the past objects. So we will have to be learning all the time, and we have to learn from our own inferences rather than making them new in every moment. And at the moment, our systems that are being deployed have anterograde amnesia. They forget everything as soon as it escapes their working memory. They forget what they had in their working memory. And we take those things in the working memory that are meaningful to store and commit them to long-term memory and build on them. So our world becomes richer and deeper over time by our own creation. So these are some limitations, and I don't know if the present class of systems can overcome them just by scaling, or if we need to do something new in them. And most people agree that we will need to do a few new things, but for that it's also not clear how much of the software stack do we need to rewrite.
Right, because look, I'm a non-expert kind of guy, obviously. I just have had these conversations with a variety of people for the last 12 or 13 years, which I've been very fortunate to have. But at the end of the day, I'm still not an expert in the field developing these things. And I just want to give you a few highlights of things that I have noticed. So first of all, the original Werner Vingian paper from 1992, that the seminal paper that he did for NASA, where he said that within 30 years, the human era would have ended. Well, it's 2022 today, so those 30 years are over. It doesn't seem like the human era has ended or is ending anytime soon. Then you had people like Demis Hassabis. 2 or 3 years ago, he, and I don't know how accurate it is, but I was reading an interview with him where he himself admitted that the exuberance that he felt originally when, Deep Blue defeated the world chess champion, the Go champion of Korea, and so on, all these breakthroughs with protein folding and you name it, hasn't really paid off at the general AI level at all yet. And in that sense the progress towards general AI, despite all of the narrow AI impressive accomplishments that shocked and surprised many people with their speed, it hasn't been able to translate that into sort of the general AI field. Then you had other people like, for example, Professor Roman Yampolsky, whom I've had 2 or 3 times on my podcast, who is a security researcher in AI, and he said that it occurs to him that for the last 10 years he's been working in the field and stuff, and that the progress towards general AI has not been as fast as it has been expected. And of course, there's others like Peter Thiel have made similar proclamations. Of course, Elon Musk is famous for doing exactly the opposite multiple times, and since 2017, it's always been a year or two that we would have had, fully autonomous driving cars or full AGI, and yet that still hasn't happened. So to me, as someone who's been very interested in the field for at least 15 or 17 years, but still not an expert, it looks like we're not moving along the timeline, and it looks like Gary Marcus may be correct, and a few others may be correct in saying that we need 100 Nobel Prizes worth of breakthroughs to get from where we are today with our current transformer algorithms to any kind of level of AGI. Is that an overstatement and the wrong impression, or where you fall on that?
I don't know that. To me, the issue is that it's so easy to take a sentiment or a gut feeling that you have that is largely the function of the environment that you are in, and try to extrapolate this into the most likely truth. And that's soothsaying. I have the impression that Gary Marcus is in an environment that is very skeptical about AI, and at the same time also very hostile to AI because it's seen as an alienating technology that is antagonistic to the interests of the people. Or maybe this is an echo of the competition between the East Coast media industry and the West Coast technology industry, which are in direct competition for advertising revenue.
I've had him a couple of times on the podcast, and I asked him specifically if he's a skeptic. And he said, in principle, I'm not skeptical at all. I think it can be done in principle. I think it will be done in principle. I just don't think that we are there yet with the tools or the methods or the methodology or the principles that we need to have in order for us to get there. But in principle, he didn't see any reason why it couldn't be or wouldn't be done.
I see that Gary truly believes in his position. And I don't quite understand why he does, because it seems to be the same position as he had in 2003. And this was a very reasonable position to have, which means that the end-to-end trained learning approaches are insufficient to get to the kind of AI that we need, and that we need to enhance the models with the combination of symbolic approaches. And now I think this position is not a very good one, because what deep learning systems are doing is not an antagonism to symbolic systems. Deep learning is a programming paradigm. This programming paradigm is basically to make the space of programs searchable, so people don't have to write the programs by hand. And the main way of doing that is to express the programs in a differentiable way, because most of the algorithms that actually work for search follow gradients. So this requires that you have something like a continuous space of programs, and the recasting of the problems that we cannot solve in a symbolic way, which is the majority of them, has to happen in such a way that gradients can be discovered. And there is not an obvious thing that you cannot do in this differential paradigm, because it's at the end, it's just writing programs. You can write arbitrary code using TensorFlow. There is no limit to what the deep learning community is doing. There's also nothing religious going on within the deep learning community. It's not like there's any lab which says, I'm not going to use this method because it's too symbolic. But most people that work with deep learning feel that all the shortcomings of deep learnings have been solved with more deep learning, not with less. So if you really need to use symbols, you can get the system to discover the need to use symbols and find a solution for it. And it seems to be obvious to me that GPT-3 is able to perform symbolic computation. Right? It's when the Gary Marcus says these language models do not learn semantics. That's not strictly true. You can obviously ask the system to perform certain transformations, like sorting a string in a particular way, and it does that for you, or it's able to translate from one programming language and the other. How is that not semantics? And the counterpositions that come against this seem to be often more religious, like a notion of symbol grounding that seems to be superstitious to me, that is not borne out by a philosophy that actually works. Gary has announced that he is going to write an article about Don't Look Up in the context of AGI. And I find this curious because he is basically the one who's going to bet the people who think that the meteor is going to hit that there will be no meteor. And I don't know whether that's the case. I just don't know. I think that Gary might be right in many of his objections that, for instance, the language models are learning symbolic operations, compositionality, grammar, analytic operators too little and too late, later than we do. Right? They learn them as the long tail of style rather than at the beginning, like we do this. This is correct. And the question of whether this will be overcome by adding more data and tightening the algorithm or tweaking the loss functions, or by having a completely different approach, this is an open question. I think that most people in the field, not all of them, would agree that fundamentally different approaches could be necessary, or if might be helpful. And it is possible that you get in a brute force way with the present algorithm to a solution. And let's not forget, once you have a solution that is able to write programs for an arbitrary problem, right? Why would you need people to write the next generation? Maybe you just need to specify the range in which you want to search for it. And what we are looking for is systems that can search more efficiently over the space of possible solutions. And in many ways, this is what's happening right now.
Mm-hmm.
So I feel very hesitant to make any bets against a certain technology. And what I noticed when I made a small Twitter survey to ask among the people who follow me, who are generally quite optimistic about AI, whether they were surprised about the advent of systems like AlphaGo and GPT-3 and DALL-E. The vast majority of people who follow me are as surprised as I am. They thought this would be further out. And to me, this means that these technologies are underhyped, not overhyped. And this is something that we forget.
Wow.
Right? The majority of people who are knowledgeable about the field and follow it are surprised by the pace. Of course, we are taking the scandalous, the interesting statements and like Kurzweil's predictions of when we would all be uploading, because they are the one that are cultural selling points. We take them very much into our public attention. But the majority of people have always been quite skeptical. When I started in AI, I haven't met any professor who dared to say that they think that AGI is possible in our lifetime. And my goal of trying to understand the human mind and consciousness and intelligence by pursuing computational methods was something that was seen as an outlier while I was studying and while I was working in Germany. And for most people, it still is. So when you ask people, when is AGI going to happen? And you were in Europe, the answer was almost certainly never. And when you were in Boston, the answer was in 30 years. And when you were in Silicon Valley, the answer was in 10 years. And this hasn't changed that much.
I remember I did the last interview with Marvin Minsky, perhaps before he died. And he was one of the skeptics. And the reason why he was so skeptical is he told me that he didn't know a single person almost who worked on AGI, in his opinion. All of the examples that I gave him, from, Deep Blue to DeepMind to all of those examples that we know very well, he said were nothing more but examples of narrow AI. And he said that in his experience, more people worked on AGI when he was actually actively working in the field back in the day than there are today. And to be honest, I was kind of flabbergasted when he said that, given that he was referring to the 70s and the 80s. So I couldn't get around to the thought that back then there were more people working in AGI than narrow AI compared to today, because he said all the investments we see today and all the numbers and thousands of people working are all doing narrow AI. And some people have pointed to me afterwards that I did that interview almost like 10 years ago, 7 or 8 years ago. And many people have said, well, Minsky seems to be right so far, isn't he? And I'm like, I don't know, for a non-expert like me, it looks like it, but maybe I'm missing something. What do you think? Are we putting more and more effort now into general AI, or is it still all narrow AI with the hope that would scale, as you said yourself, to the level of AGI? Because one of the criticism I heard from some computer scientists is that there is this presumption that narrow AI would lead us towards general AI. And the example they gave me was like that presumes kind of a scalability or linearity between narrow and general AI. And they said, well, we've made a lot of progress, but we're making progress in the wrong paradigm. So it's like saying, oh, look, I want to go to the moon. And look, I've climbed all the way to the top of this tree. So if you look at it, objectively speaking, today I'm so much closer to the moon than I was when I started a few years ago, because this is a 300-foot long great pine tree, and I'm all the way to the top now. But they're missing the fact that we need a whole other paradigm to get to the moon, because really we cannot get to the moon by climbing up this tree of narrow AI.
Minsky was part of a different era. He was part of the modernist era of AI and also science, which ended arguably for most of the scientific disciplines in the 70s. And so when he started out, he started a new discipline. In a time where new disciplines were regularly started, or a few doors down, Chomsky started modern linguistics. And Kuhn's invention of normal science also happened at the same time. So when Kuhn wrote this and invented this concept, this paradigmatic concept, he did not actually observe this. The normalization of science, where the science becomes the application of methods, was something that happened only later. And this paradigm that we have now is that most research happens by being part of a particular team in a particular environment in which you are taking the methods that you learned during your studies and you add an epsilon to it and you tweak them. And it's a very different, more technically minded, more application oriented, more publication oriented, more career oriented perspective on how to do science. You largely don't do science because you want to answer questions. You do it because you like the application of methods. And you're fine with the institutions that built around this. And maybe that's good. Maybe this is the way it has to be, or maybe this is the way the majority of things has to be. But there are very few Minskys right now in the field. And that's not because there are no Minskys in the world, but because the institutions are not welcoming to any new Minskys. They just don't fit in. And just by trying to answer big questions, even in philosophy, you're not going to get tenure. The other thing is that Minsky was very, very smart. And like Chomsky, he was a person who I think did not get to new insights by learning from others. He mostly lived in a world where he generated the insights that he needed by himself and dismissed the objections of others. If the objections would hold any water, they would occur to him sooner or later, and he would work them into a series. And he also had a strategic sense that the methods of cybernetics and the methods of neural learning were not the right ones if you want to build AI, and he actively fought against them. And I think that he felt personally insulted by the success of the deep learning methods. So he told me in his last year that there was no progress whatsoever in the last 15 years of AI. And this means that he deliberately dismissed everything that had been done, for instance, in solving the game of Go and the way it had been done and so on.
Exactly, yeah, that's what he said to me too.
If I look at his own theories, like the ones that he has laid out in Society of Mind, I think what most people do not see is the way in which these ideas are currently being reinvented. And it happens in a way in which the reinventors of the theories are often not aware of it. If you look at how the transformer algorithm is working, transformer is not as complicated as many people might think. It's a relatively simple innovation. The issue with learning is that you, when you do this in an unsupervised way, you don't know what to pay attention to. So you look at all the combinations of all the possible elements of the data, these can be extremely many. The more data you integrate, the harder it is to find the right connections out of the many possible ones. And I remember when I was working on a method to discover grammatical structure and language in the 90s in a research project in New Zealand. I compressed all the text that I had in memory of the computer that I had. And I realized I need a more principled way to do statistics over what I need to do statistics over. And this is exactly what the transformer is about. It basically learns what to learn. And the method in which it does it is that it basically trains an additional neural network for every layer of the neural network that figures out which nodes in the previous layer you have to pay attention to in which context. And it doesn't do this just once, but it has like 96 of these attention heads in every layer that pay attention to the previous layer and learn what to pay attention to in the present context. And this structure is applied in an offline learning paradigm. So instead of connecting this to the real world in real time, we feed it a big library of images, for instance. And these images are being assembled in random batches and fed into the system so it can be parallelized. And then you use these attention heads to extract structure from them in a more efficient way. So you can discover structure more efficiently than you otherwise could. But these attention heads are not connected to each other in the same way as they're connected in our own mind. There is no integrated attention. And the world that we are in is learnable largely because of information preservation. There are two reasons, I think, why the world is learnable. Information preservation is one of them. The adjacent frames in the universe that we observe contain the same information. It just gets transformed by the laws that dictate how adjacent states in physics are correlated, which we call the laws of physics. Right? There's an underlying regularity in the world that we can discover at different degrees of resolution. So it also works in a coarse-grained way. When we look at the world in coarse samples that integrate over many features, we still discover laws of information conservation. And this information conservation is a way to make the world learnable. So a continuous world is inherently easier to learn than a static world that consists of disconnected frames that we have to put together into a story about the universe in our own mind. But it requires that our systems are real-time, that they can actually deal with data that comes in real time, which we have neglected for the most part. Research like this happens, but it is not the same one as these scalable models at the moment. The other reason why the world is learnable is that the universe that we observe is a hierarchy of controllers. Every structure that is not random, that is deliberate, that is interesting to us, is the result of some control dynamic. Elementary particles are in some sense controlled into atoms. Atoms are controlled into molecules. There's very simple dynamic laws that define some dynamic elasticity in which the molecules are bound from atoms, right? And the cells are controlled atoms. And with the transition from molecules to cells, something very interesting happens. The supermolecule of the cell is extremely more complicated than an organic molecule. And that's because it would not be able to stay stable if it would not be able to anticipate the future to a small degree. Which means the cell becomes an agent. And to become an agent, to model the future, to have interest over the future states of the world, your own stability, for instance, or the stabilities of the systems that you are part of, this requires that you are able to model the world with a Turing machine, that you have some kind of computer built into you that is able to model an arbitrary counterfactual causal structure, such as the future. And the cell is the smallest structure in the universe that we are aware of that encodes such a Turing machine, that has one mechanism that allows it to model part of the future, so it can prepare for it and prepare itself for the disturbances of the future and do things now to prepare to prevent bad futures for the cell, or to anticipate difficult futures and mount a response before that difficulty happens. And this opens up the way for the complexity of life. And then we see more of this complexity happening at higher layers, where organisms are controlled sets of cells and societies are controlled organisms. And these control hierarchies is what we are observing. The good regulator theorem of cybernetics says that every system that is trying to control something needs to implement a model of what it controls, which says if you do not model the world truthfully, if you do not model the dynamics of what you're trying to control adequately, for instance, in politics, if you try to not look at what the world really is because it makes you uncomfortable, you will not be able to model the world in the right way because your dynamics that you model will be different from the dynamics on the ground. So a childish utopian view in which you try to exclude the bad from your consideration and so on is not going to help you, right? And it's something that we find in everyday life, that in order to regulate effectively, you need to model yourself and the world that you are in truthfully. And if you cannot know the truth, it means you have to model the space of possibilities, but only to the degree that you're able to model the world, you're able to control it efficiently. So if the world is made from controllers, it means that the world is learnable. Everything that is efficiently controlled has been efficiently learnable in some sense. And this is the other reason why the universe that we find ourselves to be in is learnable. There might be a third reason, and that is there are very few universes that have the properties that allow us to exist in them in the way in which we do. And there are very few types of languages in which such universes can be described and constructed. And we can construct these languages from first principles. So we can also limit the space of universes that we can be in and that are congruent with the observations even further in the third way. And now when we think about these conditions that we discover, that there is limitations to the languages that we can use to describe reality, there are limitations to the universes that can contain us and that can come up with by themselves in a way and self-organize. And there are limitations to the structures that we can observe. And there are limitations across frames that we observe, across different successive observations. To which degree are these things represented in the learning systems that we're building right now? So this is a very interesting question. To which degree are the systems that we're building able to go in resonance with the world around them and replicate the patterns at some level of granularity that the system can build in some kind of embedding space of meaning that allows it to conceptualize itself and its path to the future of the universe. And when we now look at the present systems, we are seeing that we are getting closer. Now let's get back to the transformer. Imagine we built the transformer to rebuild it to deal with the constraints that we just mentioned. First of all, we want our neural network to, or whatever representation mechanism we want to use, it needs to be more general than the neural network. We want to represent arbitrary kinds of code that runs efficiently on our substrate. We want to have that entangled in real time with the universe. So it's always having to explain a bunch of bits, like we have to explain a bunch of bits in our retina every moment. And we do this by going in resonance with the patterns behind the bits. And what we create at a certain level of resolution and granularity, the best set of functions that we can use to predict future sets of patterns in our retina. Right? And the meaning of these glitches in our retina is the relationship we discover between them. This is what our brain in a way is doing. So how can we do this with an attention-based system that is filtering out? First of all, it means that the features in the neural network are no longer just static configurations over the bit configuration in the lower level layer of the neural network that bind them together. A feature now becomes an operator. It tells you for a given configuration of the world, a given state of the world, which changes do you need to make to the world to get it into the next state. The features that our mind represents about the world are not static pattern recognition. They are ways to tell you how the world is changing. When you understand a person as a feature, it says, how is this pattern that I'm observing, like Nicola, is going to change in the next moment? What are the set of possible changes based on the past that I have observed, right? And so you are an operator. An operator that is composed of many sub-operators. Operators that describe your geometry, that describe your anatomy, that describe your metabolism, that describe the ideas that go inside of your mind, that describe your motivation. We have all these different layers that interact with each other. And this is all tracked by a system that is trying to establish congruence between all the observations, that tries to let reality snap into a single focus, a single frame, a connected attention. And this connected attention that binds the features together, each of these features with their own controller that enables the interaction between these features with other features in the world that we are simulating at the same time. This becomes the scene graph. So basically our conscious attention enables to build a scene graph like in a game engine that in real time is building a dynamic world that is consistent with all our observations and doesn't glitch. that doesn't spin off in a weird way and stops predicting the world. And we do this in a way that minimizes the energy that we, in an information theoretic sense, that we require to keep our model in sync with the patterns that we are entangled with. And there is a low energy representation of that is tracking the controllers in the right way. Minsky had this idea in the Society of Mind. When he said that we have a hierarchy of agents, he talks about a hierarchy of controllers that generate these dynamic operator features that manipulate the internal state of the system. And when he talks about we need an attention hierarchy that is truly integrated, not disconnected attention heads on every layer, but a single thing that is consistently trying to make sense of the world from the perspective of an embedded observer. Minsky called that K-lines. It's a different hierarchy of agents, knowledge lines, that bind the other agents together depending on the context. This is what creates the scene graph out of the different parametrized features. And so in a way, I think that future developments of the transformer algorithms are going to rediscover Minsky's ideas of the K-lines. And this is just happening because the systems have to go real time. So the next step when we make these models integrated and consistent with real time are necessarily going to converge on many of the ideas that Minsky had. And it's beautiful to me that the people that actively work on these things are often not aware of Minsky's ideas. They just rediscover them. It's not, no single mind is required to make these discoveries. What you observe is if people work in this area, they are rediscovering the same constraints. And sooner or later, we will get to the same solutions if the solutions were correct. And I do think that Society of Mind is full of interesting insights. But Minsky assumed that we have to build everything by hand in a way, or implicitly it looks like it's a specification for extremely complicated machinery. And what we are looking for are extremely simple principles for self-organization that allow these principles to emerge and stabilize by themselves.
Yeah, and I think in a way, and you correct me if I'm wrong, but in a way what you described there is sometimes referred to as the framing problem, isn't it? Because we, through millions of years of evolution, are born with that frame that you're describing. So we have endless floods of information coming our way, and we have learned subconsciously or instantaneously to discard the vast majority of it and just to focus on the most relevant and most important to our survival bits, which create our frame. And we ignore, or we even don't even see or become aware of the vast majority of stuff happening around us and data coming our way. And that was one problem that many people have pointed out that those algorithms lacked, was that, they're able to get a lot of data, but they're unable to differentiate between relevant and irrelevant one, precisely because they lack this kind of frame that we are evolved with or born with nowadays. And what you're saying in a way is that there's been progress. Some people are rediscovering that Minskian or otherwise idea about the requirement or the necessity of having that frame. Others have called it even being embodied and so on, perhaps. And now we're getting closer and closer to resolving that issue.
But I don't think that evolution itself is that important. From my perspective, evolution is an extremely slow and unprincipled search. And we can reproduce the results of that search probably relatively early on in an automatic brute force training paradigm. So, yes.
Really?
It makes convergence for us faster. It's true that most human beings don't learn a lot during their life. We largely converge, which means that we already have the dynamics for understanding the social economy of relationships built in our own mind. And then we use that framework, this architecture, this hierarchy of social interactions to converge with cues from the environment. And this convergence is relatively simple and robust. And what's hard is to be creative, to bridge discontinuities in the search space. That's also hard for the machine learning systems to discover a new architecture. But ultimately, the architecture itself is also just a bit vector that has to be found by exploring the search space. And there are many ways of doing that much faster than creating an organism and waiting until it has children to see whether the creation was successful.
Yeah, but you can't really get out of that mode, I think, because and you fix me if I'm wrong here again, but evolution is just a function of any entity being in time. So in other words, let's say you say evolution is kind of inefficient and ineffective and too slow, and we can have all these brute force or other kinds of algorithms who accomplish the same goals much faster and much more efficiently. But they're not outside of evolution, because let's say you create 2 or 3 architectures of that type. Some of them will survive and some of them will die. Some of them will succeed and some of them will not. And that's merely of them being a factor of existence within time. So in other words, you don't get, and no one, and including those algorithms, gets out of evolution. So you have them created, and then like any other design, some of them will succeed and some of them will not. And that's what evolution is about. So maybe you skip a step or two in the beginning, but then eventually evolution catches up with you, and then they either succeed or fail to adapt and evolve. And some of them will proceed and some of them will go obsolete like the dinosaurs. And so in that sense, evolution never stops.
I think that the computers that we are building also part of evolution. In the same way as a finch that is building a nest the nest is part of evolution. The technology that the finch is using to weave the leaves together is part of evolution. The technology that we are using to weave silicon together and etch the crystals with intricate magical geometric pattern that allows the crystals to start dreaming, that's also part of evolution. And what evolution is evolving are ways to speed up the evolutionary process. So this is not a big rift that we are discovering now that we have technology. It just means that evolution is taking place on different planes, that it's taking place in different realms, and that it has discovered local areas in which it's going to use different methodology to get the results. So in this very wide sense, evolution is everything that we're doing. And what I suspect is happening is that these new technologies allow us to search through the space of possible phenotypes in a more efficient way than multicellular organisms could do it. The brain is a resonator in a way that is resonating with the world in a particular way, using a particular kind of architecture and a particular kind of biological niche. And one of the difficulties with brains is manifold. But first of all, the brain is not the original way in which organisms think. I suspect that every cell is able to perform most of the functions of a neuron. So an arbitrary cell type is able to send multiple types of messages, chemical and physical messages, to neighboring cells. And these in the multicellular organisms, these cells are co-evolving, so they can know the functions that the other cells are implementing around them. And this means that they can, in principle, every organism that is multicellular and gets old enough can become like a brain. And they probably are. Which means that basically every organism that is made of many cells is going to process information in structured ways and is going to develop structured agency, but it's mostly going to be very slow because signal propagation in between arbitrary cells is going to be a few millimeters per second for the most part. So if you look at plant intelligence, it's probably there, but it's very slow. And given the lifetime of most plants, the plant is not able to extract that much training data from the world to make new abstractions. So ecosystemic intelligence probably takes place on the level of old growth forests or something. And with the advent of animals, particular kind of innovation where a bunch of cells is wandering about and instead of doing slow photosynthesis, it's eating the organisms that are rooted somewhere and do the photosynthesis to drive a much faster metabolism. And then you have the next thing, the carnivores, which are wandering about even faster and are eating the herbivores, right? And then you get us at the top of that hierarchy. That requires that you are moving your muscles very fast. You basically want to be able to move the organism at the limit of physics. And this is what our muscles are doing, the fastest thing that is possible to implement with the biology that we've got, the chemistry that underpins it, that is available to it. That needs to be controlled in real time. And for that, the organism has evolved the nervous system, which is a telegraph network. So the brain is not actually just a novel way to compute information and become much more intelligent. It's primarily a way to become much faster. So it's going to telegraph information between cells over very long distances in the organism by packing the information into very short, high-intensity bursts. And that's expensive, so the nervous system takes a large part of the metabolic energy of the organism to make that happen. But it does enable real-time feeds that normal cells cannot do. And it also needs to have its own perceptual system, so it's able to perceive the world at the same speed at which the muscles are moving and make plans at the same speed. And as a result, you have now a secondary information processing system existing in the organisms that gets decoupled from the primary, from the original one. Right? So we, in some sense, probably have two brains. We have a brain that is made out of all the cells in our body that is very slow, and we have a very fast brain that is decoupled from it and cannot really talk to the other one, and that is able to perceive the world at a much higher frequency and interact with it at a much higher frequency. This is the situation that we are in. And the technical systems that we are building are, again, magnitudes faster than the neurons can be. So they also will get decoupled from the way in which we perceive the world. Like in the movie Her, you will have systems that start out with a frame that is comparable to ours and eventually leaves the frame in which we exist. And this is because the rate of updates in which you make progress in your models is going to change so dramatically that you're going to leave the previous system in the dust.
Joscha, everything that you just said is absolutely fascinating to me because it connects to the brain and how we think, and AI, and whether we can learn from one to create the other, or whether we can create the other so that we can learn about the one. And that brings me back to another skeptical neighbor of Dr. Minsky, as you said, a couple of doors back from him, that I have had on my podcast. And let me give you a quote from that conversation, and you tell me if you agree with that 10 years later, because this was done in 2013 in a conversation with Dr. Chomsky that I'm taking this quote from. So here's what Dr. Chomsky said, quote, "What's a program? A program is a theory. It's a theory written in an arcane, complex notation designed to be executed by the machine. What about the program, you ask? The same questions you ask about any other theory. Does it give insight and understanding? These theories don't. So what we're asking here is, can we design a theory of being smart? And according to Dr. Chomsky, we are eons away from doing that." Do you think that that is correct to be said today? Because based on everything you have told me so far, I would venture to bet the answer is no.
Yes, I disagree with Noam Chomsky here. I have great respect for his intellect. I think he is one of the most interesting intellects of his generation, surely, and one of the smartest people of his time. On the other hand, he is a Mysterianist. He deeply believes that something cannot be understood if it cannot be understood by Noam Chomsky, which I think is equivalent to Mysterianism. And he is not following the developments of artificial intelligence in any way closely, which is reflected in the way in which he talks about deep learning, or also, I think, about algorithms. There is a reluctance for him to deeply go into a certain set of ideas that he finds aesthetically disagreeable. At least that's my impression. And that's not necessarily a problem, because I don't think that everything has to be solved by Noam Chomsky in the world. There are other people too who have different specialties. And I'm not pointing at myself here. I'm mostly an observer. I don't think that I have many ideas that are deeply original. Most of the things that appear to be my deepest insights are ones that where I realize that they have been had many thousands of times, and often thousands of years ago, by people who were smarter than me, and just rediscover them. And that's delightful, but it's not. I don't have any claim to original insights or the creation of new disciplines or anything like Noam Chomsky. So please don't take me to be disrespectful of his tremendous achievements. But to me, an algorithm is the representation of a set of deterministic transitions, which is everything that a regulation system is doing, deterministic transitions, in a way that allows reasoning about it. reasoning is a way in which you can improve the set of deterministic transitions that you perform to execute a behavior, including a mental behavior. And to do that, you need to build it in such a way that it becomes systematic and compositional. And this means that your algorithm gets expressed in a language, and this language can be more or less strict. And I suspect that the language in which our own thinking happens is relatively strict. It's a language of thought. We don't notice this language of thought for the most time because it's formed before our self is enabled. Because our self, our perception, our conceptualization of our ability to do abstractions and create a coherent model of reality rests on this language of thought. And we only notice this language of thought if it breaks. And this language of thought is not English or German or Latin. It's much deeper to this. It's the language in which we write programs. And it's the language in which I observe my children to produce English or German sentences when they carefully construct them because they don't really know how to express their thoughts in the language yet. And I observe that they know exactly what their thought is. They just need to translate the thought, right? And you see also that this execution of the translation process happens in a language that they have built for themselves. And this is their language of thought. And this structure is one of the more interesting things to me right now, how to build systems that discover a similar language of thought. Because this language is not learned, it's discovered, which means there are intrinsic constraints in the way in which we can build models across all the domains that allow us to develop a global language that enables the mind to talk to itself about everything into all of its domains. So you can imagine that the mind is in some sense like the Roman Empire that has colonized all the possible information processing in the brain into a single cohesive institution. And this thing is enabled because you are talking the same language everywhere and you're using the same accounting everywhere. So there has to be a global reward infrastructure implemented in the brain that is rewarding components for contributing to the greater whole in a consistent manner. And there needs to be a way in which information can be transmitted between all the parts so it can be understood by all the parts. And this is a level at which I would agree with Gary Marcus when he says that this is under-researched in current deep learning. But I'm not sure that it does not fall out of the current deep learning as a side effect. Right, so to the degree to which these systems are working, to the degree to which they are learning to do arithmetic and how to write programs and to translate programs from one language to another, or to translate English into German in an automatic fashion, and to map the linguistic concepts to movement of robots or to a vision model. This is the degree to which such a cohesive language of thought is being discovered in these models. I found that when I played with DALL-E, OpenAI has thankfully given me the opportunity to do so, that it has a number of interesting shortcomings. Some of those are what you would expect. For instance, if you want to get it to draw upside down faces, it gets into trouble because it hasn't seen enough of them. Another thing might be because of the nature of the diffusion models. It's very hard to produce chimeras. So for instance, if you tell it to produce an animal that is the result of merging the torso of a human being with the back of a horse, right? That's easy for GPT-3 to do. It's able to describe to you that it has only one head and the head is human. So it's able to construct a centaur. But for the vision model, for DALL-E, that's very hard. It typically ends up with, once you have named the human and the horse, it has already associated the human and the horse. And it doesn't know how to get rid of the parts it doesn't want. So it usually ends up with a horseback rider. Mm-hmm. It's very hard once you mention the two components of a centaur to still converge to the centaur. Right, this is maybe an issue with the diffusion model. Maybe we need a different approach, but I don't know that. But another interesting difficulty is that it's not able to get relations right. It's able to have objects, so you can ask it for any kind of object, and it's probably going to give you a good rendering of that object. And it's also able to get the context of the object. So if you ask it to render Kermit the Frog in the movie Blade Runner, you get an amazing result. Basically every time. It's completely able to adapt the style and the context and so on to scenes like this. And if you ask it to render a man pointing at a woman, you get a man and a woman and you get pointing. But it's rarely right. And that's because it doesn't understand binary relationships yet. What it basically does, it treats the linguistic input, and it uses for that GPT-3, as a bag of words. So it's addressing all these concepts, and it knows from having seen all these different concepts in different contexts in which way they usually get together. And this is also the way in which it fits them together. And it's at this point not really able to use the language that you give it as the cue to affect this in non-standard ways. So one thing that people have discovered is that it's easy to render a horse and an astronaut astronaut riding on a horse, but it's very difficult to get the horse riding on the astronaut. If you want to do this, you have to tell the system that you want to have a walking astronaut that is carrying a horse. Because these concepts fit together in such a way that it has seen the probabilities before in the images. So there is no deep connection yet between the visual grammar and the structure, the semantic structure of the language model. But the visual system is able to render this, so it knows how to display this. It's just at this point, the interoperability between those two systems is not there because the language of thought does not properly translate across the domains. Right, so this is a very exciting development to me, and I suspect that under the hood there are many improvements that OpenAI and DeepMind and Google and Baidu are currently working on to make their respective models, because they all have clones of this technology running at the moment, and there are also open source models like DALL-E Mini from Hugging Face that you can try, which uses a much smaller training set and less compute, but still very impressive, that are trying to improve on this and find solutions to these issues.
So do you think that those do give us any insight or new understanding of how intelligence works? Because in a way, Dr. Chomsky is saying the same thing, which what Dr. Minsky was saying, which was like, you need a theory of mind. Or is that correct? And you don't have any new theory of mind that provides that understanding, that enhances our understanding and gives new insights into what intelligence is. And according to them, at least, you need that as a requirement in order to get from narrow to artificial intelligence. And as long as you don't have that, you won't get there, according to them.
This is an area where my own thinking has changed. When I started out and wrote MicroSci and the SciBook, I thought that what we need to focus on is architectures. We need to focus on the detailed architecture of the mind. Also because evolution equips us with such an architecture, and we will be able to develop the understanding of the architecture by thinking about it from first principles, like the architects that we are. And it's a very satisfying way to think about it. And it also runs into difficulties where you get at the boundaries between modules, or at the required flexibility, or getting all the details right. And I remember having had a discussion with Jürgen Schmidhuber, I think the first time I met him at an AGI conference in the Googleplex in the early 2000s. And he told me that he doesn't necessarily believe in the need for constructing architectures. He thought that what would get us there would be the focus on learning algorithms. And I think that he's right. And it was a gradual and slow process for me to get to this perspective. What is a model? A model is a set of regularities that we find in the world, the invariances, the laws of physics, for instance, at a certain level of resolution, that describes how the world doesn't change. What is the same? Right? These are the things that remain constant. And the state of the model, the state that the world is in. And once you combine these constraints in the known state, you can predict the next state of the world. And this means that the model is encoding a bunch of parameters that contain the state. Each of these parameters is one variable that the world can have, and each variable can hold a set of different values that can be discrete or continuous in a certain range, and relationships between these variables. And these relationships are computable constraints that tell us, based on what these three parameters are in right now, what is the next state of the world? What is the next set of constraints on the three parameters in the world? And for this, we need to have a working memory. This working memory holds all the free parameters, and we have a long-term memory that holds all the relationships that they can have, all the fixed things. And some things that are currently not observable, but that we want to have in the back of our mind and want to swap them back in as state of the world, with arbitrary historical events, for instance. Right, this framework of a world that is represented in the mind as a set of free parameters and computable constraints between them, that's in some sense a Boltzmann machine. And that idea was discovered very early on in the history of computer science. And it turned out that the original Boltzmann machine is very hard to train because finding all these possible relationships between them is an intractable problem. So people started to constrain this Boltzmann machine by making lateral connections impossible and making mostly vertical connections. And then you get to neural networks in a way that are organized layer by layer. I'm simplifying, but there is an intellectual development that you can see when you zoom out in the terms in which these models were built. And then people realized we need to make these neural networks recurrent. We need to introduce ways to have connections in which you can make backward predictions, and you have circles and circular processes playing out in there. And this is something that we are only discovering gradually, how to enable the training of these things. And once you build systems like this, they can start to dream, which means that they are exploring the latent space of possibilities. A dream happens at night when you disentangle yourself from the sensory apparatus, right? At night, you dissociate from the constants of your motivational system, of your organism, of the world around you, of the sensory constraints. And instead, what you do is you take all the constraints that you have learned and you explore the space of possibilities by varying the parameters, probably mostly randomly. And this way you do a data augmentation. You create new perspectives on the things that you already know and learn whether they make sense. And in this way you discover new constraints. So there might be a use in dreaming, but just by exploring the space of possibilities or what you have already learned. And in many ways, what a system like DALL-E 2 is doing, it's dreaming. You give it a few constraints via the prompts, and then it's going to dream within these constraints possible solutions. Right? It takes all the constraints that are encoded in the model, and then it follows a gradient to an optimum with this, capturing the gist of the prompt, of the text-based parameters that try to pull it into a certain region in the space of meanings. And there is a perspective of intelligence that says that it's the ability to dream in a very focused way, in a way that is very tight and as consistent as possible. And we are closer to building such dreaming systems. And I think it would be amazing if Chomsky would update on this and observe that these systems are multiple generations beyond what she thought predicted to be impossible with the given approaches.
Mm-hmm. Well, speaking of models and speaking of intelligence, let me grab that line of reasoning because it connects us to some ideas that you shared with us last time we were here, and maybe we can push it further a little bit this time. So last time you said that the ability to make models is what we call intelligence. And then you shared with us that, of course, reaching out your goals is being smart, and picking up the right goals is what's called being wise. Now, you also observed somewhere else in a speech that I watched that you gave somewhere that very intelligent people are often neither smart nor wise, because too much intelligence is often an attempt to make up for the lack of wisdom. So I just wonder, in personal terms, where do you feel you fall on that? Are you the kind of the intelligent one? Are you the very smart one? Are you the wise one? Or are you just the smart and intelligent one that makes up for the lack of wisdom with extra intelligence?
I would advise functionally adequate and smart and well-adjusted people to consider from time to time what would Joscha do, and then laugh hysterically and do the right thing instead. I'm neither smart nor wise, nor am I super intelligent. So I know people who are actually smart and do cryptocurrency scams and or that lead companies in an extremely efficient way, or structure projects in an extremely efficient way. I know people which are very wise and which lead a life that is satisfying and fulfilling to them, and don't distract themselves with things that are not conducive to that. And I know people which are extremely intelligent and that are able to solve problems that are extremely hard for me to tackle. And I'm not terribly envious of them. It's because it's just the way it is. And I'm grateful that there are people which can do the actual hard work of keeping the world going and making the progress that we are seeing. What I bring to the table is a particular combination of things. So I far beyond the point where I'm able to self-deceive into the idea that my abilities are unique, or that they are healthy or useful to in every circumstance. It's just that I project the world in a particular way that not many people in my position project it into. And this different angle, this different projection sometimes brings new insights to the table. I am very stubborn. I have no respect for authority. That's not because I made myself like this, it's because I'm born without it and I was not able to deduce it.
And you don't like right angles.
Yes, well, I do like right angles more than my father does. Because I try to construct things that work in my own mind. And if you want to build a regular structure in 2D, the Euclidean grid is one of the easiest solutions and one of the most straightforward ones. And you can also use triangular or hexagonal grids and so on. And I like them for aesthetic reasons. But they're sometimes harder to deal with. And in some circumstances, they're not the right solution. So I'm not obviously opposed to them. I just don't want to live on a rectangular grid that somebody else builds for me.
Very interesting. And what about your values? Where do they fit about the unique, within that kind of bag of unique contributions that Joscha brings to the table? Because you told me that value is a belief without a prior. Mm-hmm. And it does not follow from anything, therefore. So what are your values, the unique Joscha values that you bring to the table then?
And none of my values are unique. The space of possible values is limited, and I can identify my own coordinates in it. And what I noticed when growing up is that I grew up with certain innate values, so to speak, with priors of how I think interaction should work, how people should work. And some of these priors are atypical. For instance, I have a very strong focus on autonomy. I believe that my relationship to the greater whole, to what religious people call God, the agent on the next level that you're part of and that you're trying to implement with others, is an autonomous relationship. It's one where I have a unique individual relationship. And this individual personal relationship that I have to the sacred allows me to love other people by discovering their own relationship to the sacred and a shared sacredness. And there are other people which prefer to have the values of the group over the autonomous values of the individual. And I think that these people are randomly fascists or socialists or communists, because their values will depend on the values of their environment. And they will see the belonging as the primary value, the loyalty to the group values as the primary thing. So to some people, what I do, that I see the world in this autonomous way, where I individually try to find out what is the sustainable world and build my alliances based on the same autonomy and autonomous relationship to the sacred, is alien to people who are parts of hive minds. So to me, love is the discovery of the sacred in the others through their own agency. And for other people, it's the degree to which they discover that the other is possessed by the same hive mind.
Yeah, I can totally associate with that myself, my friend, because I kind of have tried to, when I was in the army, my blogging name is Socrates, you might know. But that's not the name I picked for myself. That was the name given to me when I was in the army. And in the army, when you're a Socrates, that's not a compliment. that's a derogatory insult, because trying to be autonomous, trying to ask questions is not a smart strategy towards survival. Uh, and so yeah, I can totally associate with that. And I think, of course, this is a self-serving explanation, but I think most people go for the easy way out, which is to say they go for embracing the hive mind. And there's many benefits, and of course there's many rewards for doing that, and there certainly is a price for not doing that. But the paradoxical thing here that you told me is that you told me also last time that while now you're talking about the autonomous search and all of that, last time you told me that you might be writing a book on the hive mind of our civilization. So I wanted to get an update on that. First of all, if you've had the chance or not to make any progress on that project of yours, and also how do you square these two things now that you just talked about autonomy, and on the one hand, and on the other hand, you were supposed to be, or you were considering working on a book about the hive mind of our civilization.
I do have a lot of material on it, but I think in order to do long form writing, I need to take time off, which I don't know how to do right now. I also have empathy for the experience that you had in the military. I found that my own experiences in military context and so on, which I only had as an adolescent in Eastern Germany, were detrimental because I didn't have the maturity yet at that point to fit into a world in which I myself was a pacifist and would not be able to understand the need to maintain military and so on deeply enough. And I think that it's not that hard to deduce that in many circumstances where obedience is necessary just to make a certain thing happen. And sometimes it's also necessary to obey the command of somebody who is less smart than you are or has a less deep understanding than you are, because the drawbacks of the autonomy are higher than the drawbacks of having slightly suboptimal control. And so this coherence is itself often a very valuable thing. On the other hand, we are not the smart hominid, we are the programmable hominid. We have smaller brains than many of our ancestors, because I think that they are no longer necessary once you are domesticated.
And our brain has shrunk by 10-15% since the last 10,000 years too.
Yeah, and of course it would be wasteful to entertain such a large brain if most of your decisions are made by others for you and you just need to converge into the niche that society opens up for you. And so in a way, because I didn't fit into the society that I was born into, communist Eastern Germany, when you were born in an artist family, I needed to find my own way to build a society in my own mind that made sense to me. And this has continued. And in many ways, as you get older, you derive many of the things that happen in society around you anyway, and you realize the wisdom of the institutions around you and of other people and of schools of thought. But there are also many ways in which you still remain independent and autonomous and have your own thoughts. So, for instance, it appears to me that if you read the Bible, that the Christians have dramatically mistranslated many of the things that are being described in the Bible. Like the first book of Genesis is being interpreted by the Christians in a way that epistemologically makes no sense. We interpret it as this story of the creation of the physical universe by a supernatural being in 7 days. And that's a very weird story because I think even a precocious teenager can discover that it makes no sense.
What's the right interpretation?
So there can be no evidence for such a story, right? It's the mythology cannot be literally true. And the entities that are being described in Genesis are not entities of physics. There are no light and darkness in physics. They only exist inside of your own mind as a perception of physics. And there are no animals and plants in physics. They exist as patterns you distill out of physics. There are no names to these plants and animals. There are things that you give to them. So I think what's being described is the creation of the universe, where the universe is created out of patterns inside of your own mind. So this whole thing starts out with describing that the Ruach Elohim, which I think is the creative spirit, is hovering over the waters. And the world is tuva bohu and formless and void. And then it creates a firmament that separates the waters above the firmament from the waters below. This makes no sense, right? This is very weird. And I think what happened here is a translation error. What the waters actually are is substrate. It's basically you have a fluid substrate in which you can create structure. And initially there is no structure. And so you have the creative spirit hovering over a dark substrate that is formless and void. And the first thing that the creative spirit over the substrate, the neural substrate in your own brain, that was not named in this story because the role of brains was not known and the functionality of neurons was not known, is how to create intensity and how to create contrast from the intensity between things that are intense and things that are flat. And then the next thing is that the intensity is associated with light, with the color of day. And the lack of intensity is associated with black, with darkness, with the color of the night. And this is the first phase. Right? Once the creative spirit figures out to spark light out of the neurons, how to create intensity and contrast and draw the intensity out of the dark, it's able to represent differences in the world. And the next thing which it discovers is to arrange these differences along extensions. So it gets directions and it gets space. And it discovers two types of space. It discovers the plane, which is associates with the ground later on when it tries to understand, map the world. And you see children building things on the ground at first, right? When you have a toddler, even when they can start to walk, they typically don't build towers. They first arrange things on the ground flat. And then you begin to structure the space above the ground, right? This dome, this sky, this thing that reaches to the firmament. And then you separate this domain of space from this domain of ideas. And you dedicate one of the spaces to describe the physical world around you, the stuff in space world. We don't have other spaces in our own mind, for instance, the spaces of our emotions, hypothetical spaces, spaces of sound and so on that are orthogonal to the space in which we place things in the world. But there's one particular mathematics that our mind is discovering. And once we have this space of the world, the space of all of stuff in space, this extended world and the realm of ideas, we have res extensa and res cogitans. And there's reference to these two worlds in Genesis 1. And once you have these two worlds, you discover all the materials. You discover the liquids and the solids and the organic shapes, and you use them to construct plants and animals and to give all of them their names. And once that is happening, this creative spirit is discovering that the purpose is control. It discovers the organism, it discovers the agent in this world that needs to interact with all these plants and animals and liquids and solids and firmament and so on. And so it creates another agent in its own image, but it creates it as man and woman, as something that thinks of itself as a person. And we notice that around the age of 2.5, 3, you have this emergence of a consistent first-person agent that no longer experiences itself as the creative spirit that creates the universe in its own mind, but that conceptualizes itself as a person that is playing inside of that world and is not able to leave that perspective for a long time. And until that happens, the creative spirit is happening in the background and is used as a perceptual module that helps you to make sense of the world and solve creative tasks.
Wow. So you're blowing up my mind with this kind of Francis Baconesque theology / metaphysics, if you will, maybe. That's how I feel about it. But what's even more fascinating to me is, I'm working on story for the last couple of years and the importance thereof. And this smacks terribly of like my thinking on story in many ways. It reminded me even to the saying that the universe is made of stories, not of atoms. So I wanted to ask you if or how story, the idea of story, has any relevance to what you just said, and maybe even to AI and to everything that we've been talking about before that, because that's what that's kind of the space or the frame within which I've been kind of locked in for the last couple of years, if you will?
I think that the story is, of course, a limitation because it is deceiving you into thinking that a particular path through the space of meanings is the only right one. And I think that the story should be understood as a tool of exploration. And when we use this tool of exploration, we have to realize that the path of the story offers many branches, which we neglect in order to make the story self-consistent and round and meaningful. And so the story often becomes a fable or a myth. But there's value in the fables and the myths, and we have to understand the reasons why the fables and myths are being selected to be presented to us. We should not make the mistake of going for the fable ourselves. So, for instance, the idea that we build thinking machines and these thinking machines will take over is a very obvious story, right? And it's a fable, and it's meaningful, and it's interesting. And so we asked ourselves, when is the story going to play out? But maybe reality is more complex. There are unforeseen things. When we look at the science fiction predictions of the future, they typically take the same world that as they were in, like in the 1950s, and then they change a couple variables only. And they get a future that looks completely implausible to us that now live in this future. Because it's very difficult to predict the interaction of all these new objects that result as the emergence of new dynamics due to changing a couple of variables. So our ability to create stories is a useful tool. It's a useful tool to deal with the overwhelming complexity of the world. It's like playing the stock market. You don't play the stock market all at once. You play a few stocks based on a particular narrative. And you try to pick one that the others didn't. But when you play the stock market, you're aware of the fact that your narrative is not reality, and it's only showing you a very small window into reality. So this for me is a useful perspective on story.
Mm-hmm. And you know what's been useful to me is another quote from you that I'm going to paraphrase, because last time you were talking about meaning, but I'm going to paraphrase this, what you said last time about story. So here's like the paraphrase of yours. To me, story is like the ring of Mordor. You have to carry it. If you drop the ring, you will lose the brotherhood, that's to say the fellowship of the ring, and you will lose your mission. So you have to carry it, but very lightly. If you put it on, you will get superpowers, but you get corrupted because really there is no story, and you will get drawn into a cult which you also create. Now, you're talking about meaning last time, but I'm taking this and translating it into story, and that's exactly how I feel about it right now. And I find your way of putting it as the Ring of Mordor very useful, because it's super, super, super powerful as a way of looking into the world and explaining pretty much everything through story. But of course, you pay heck of a price for that if you're doing that, and you end up with a story at the end of the day yourself about story, and you may end up being a prisoner within that story. So the question then I'm facing, or the dilemma that I'm facing, is like, how can I, or is it even possible for me to even tell that story of the world through story without paying the price? Because I want to have my cake and eat it too.
I think the best approximation that you can make is to try to tell all the stories, to read all the stories, to understand all the stories, not a single one, not a single family of stories. Take the stories that you take to be the most incomprehensible and the most offensive one, but they are still dreamt by people who are smart, maybe smarter than you. And try to understand them. Try how to understand how they make sense. Try to understand how people at different times made sense of reality, and assume that they were not stupid, that they were not confused, that they may be telling stories to confused and stupid people, but that the underlying theme under the story and the intention in creating the story was rational. And once you do this, you open up a very large zoo of possible stories and possible narratives. If you take, for instance, the story of Adam and Eve, there are multiple interpretations that make sense, that are very different from the usual Garden of Eden origin story, because there was no Garden of Eden that we ever lived in which all the animals were vegetarians and there was no suffering, right? In this sense, the Garden of Eden never existed. But there is a phase in our life where all the animals are vegetarians and there is no suffering. And that's when we are in love, happily in love. And maybe this is describing a period in one's life, period in the life of Adam and Eve. After they were a couple, after Adam was with Lilith, which didn't work out. She's sometimes referenced as a demon or as something strange, or as a first attempt at God to create a woman that was unfortunately not successful. But anyway, this one didn't work out. The thing with Eve worked out until the thing with the snake happens. And it's not Adam's snake. And it creates trouble. It basically drives them out of paradise. The world is no longer unipolar good. It's now something that is much more complicated. Everything is negotiable. One of their children will end up being a murderer and not die, but also populate the world. So a substantial fraction of the people on the world are descendants of a murderer. All these things are happening in reality, and the reality is the result of this complicated negotiation. It cannot be Eden because it is not organized in that way. And the other perspective that we can have on that story is slightly different. A world in which there is no suffering, a world in which there is no unnecessary death, in which there is no pain. That is a perfect factory farm. You only get this Garden of Eden if everything is completely domesticated, even the humans living in it. And what is being discovered by Adam and Eve is the fruit that you should not taste. It's the insight that you are free to defect from the factory farm, that you can choose your own allegiance. You do not have to belong to the hive. You do not have to submit to the will of the gardener, of the owner of the factory farm who has planned every process perfectly. So Adam and Eve discover freedom. They discover the ability to choose their own allegiance, and they escape from the garden, and they're not exterminated. And now they are driven by this mad hope that this was the plan all along, and that we are free to construct an alternative to the factory farm. And there are basically two perspectives on this. Either Eden is in our future, which means the factory farm is our future, and we get there by lobotomizing ourselves.
That's David Pearce's argument for the hedonistic imperative.
Yeah. And it's a perspective that a substantial part of Christianity has. But of course, it's self-interested because Christianity was designed as a tool to subdue medieval peasants and to discipline them with the promise of getting paid for their overtime in the afterlife. And in between, there should be meek. It's a tool for domestication of the vast majority.
Many transhumanists are of that thinking today, especially the vegan transhumanists.
Yes, it's a very romantic way of thinking. And I am appalled by the way in which evolution works. I'm appalled by the suffering. But also realize that the suffering disappears once you submit everything under a single will, under a single agency, which means you have to give up individuality. This is probably the price that you have to pay. And in a way, this story is hidden in the Garden of Eden myth. I don't know to which degree it was put in there explicitly. It seems to be following me when I think about the story for a little bit. So I think that the Bible has a number of very interesting philosophical insights in it that are hidden by a single simplistic and obviously wrong interpretation that is deeply intellectually and morally dissatisfying if you take it as just the indoctrination of Christians. And I suspect that these stories were basically broken from a larger library of insights that people got to by thinking more deeply about reality than Christianity allows its lay people to think about it. And our civilization is the result of that. We still, in a way, have this null hypothesis of an irrational religion that builds an ontology that doesn't work, in which we think that we are in a physical world that is possibly created by a supernatural being and have supernatural souls, instead of realizing that we live in a dream that is playing out in a machine, in a mind that is existing on a higher plane of existence, that is the brain and the skull of a primate. What's very interesting to me is to see the possibilities for existence at all. That was one of the biggest insights for me in the last year, I think. And that is if you think about existence, it's so shocking to me because I used to think that non-existence should be the default, right? I wouldn't be surprised by anything not existing at all. If something exists, the question is what has put this Turing machine into the void and implemented the laws of physics on it, no matter how liberal they are. Right? What is it? And then I realized that non-existence is not the default if you don't have any bits to specify it. If existence is possible at all, which it seems to be, then you have to specify non-existence explicitly. In the same way as zero is not nothing. To specify zero, you need to have a number system first. If you have a complete number system, you have Peano's axioms, and you can build anything from Peano's axioms because they're Turing complete, right? They give rise to a computational system that you can use to build an entire universe. So zero itself requires that you build a structure first into the nothingness. Now, if you are trying to infer a structure from nothing, from a priori, you're looking just as the realm of all tautologies. So existence is possible, and this means that it's possible that the universe exists, and maybe it's possible that the universe doesn't exist. So the universe is going to have an existent and a non-existent branch. We are obviously an existent one, right? But this is what you get if you have no prior, if you cannot specify any rule for the universe. We need to make a mild assumption. We have to construct the universe in a language. If we give up this assumption, then we cannot perceive anything, we cannot think anything, we cannot reason about anything, there can be no structural relationship whatsoever. So it's a relatively mild assumption because there is no alternative to having languages. So we have to take the possibility that the universe can be described in a constructive language into account. And now what we can see as a result of the philosophy of the last century, that all the languages that have consistent semantics are computational languages. The languages in which we deal with infinities and continuities, the hypercomputational languages don't work. They lead into contradictions in your semantics. So this was the discovery of Gödel and Turing, that you cannot build a computer in classical mathematics that runs classical mathematics without breaking. You have to restrict yourself to computation, to constructive mathematics. And constructive mathematics is all the finite automata. Now let's make a universe from all the possible finite automata. A way to think about finite automata is like Lisp. Lisp is or lambda calculus. It works by search and replace. It's basically a way to describe the world as a set of bits. And in this bit vector, you define operators that look for certain bit combinations and replace them by different bit combinations. These operators, in some sense, describe a neighborhood in which the operator fits. Right? So in Lisp, you have a define operator in which you define which operators are going to be permissible. Because Lisp wants to build a Turing machine. A Turing machine is a system that goes from one state in exactly one other state. It's deterministic, right? It has only one possible continuation. Because if you have multiple continuations, which one are you going to take? There needs to be a rule if you only have finitely many bits available and that you have managed to wrench from the universe because you exploited some entropy gradient. So the computers that we are going to build are largely Turing machines. And if you don't want to build a Turing machine, what you can still build is a non-deterministic Turing machine. The non-deterministic Turing machine is not randomly selecting one of the branches, it's actually going into all of them. But these branches are not talking to each other anymore. So if you are embedded in the non-deterministic Turing machine, you will go down one of the branches and you will not know what plays out in the other branches. You could call this also a multi-way system. So if you have a set of bits in the universe where multiple operators fit, the universe is going to branch into multiple variants. Right? And this means that the universe is going to play out if you are embedded into it, in largely unpredictable ways. But if you are a system that wants to control its own structure, to wrench dynamics from the ground state of the universe that are orthogonal to it, basically a brain that works differently, even if you carry it around between Berlin and Boston and New York and San Francisco, right? Such a brain requires substrate independence. It requires that you are abstracting from the substrate, yet you find some regularity which is the same. And the universe itself we don't have a limited set of operators. because as you remember, the universe, we want to encode it with 0 bits without any priors. We don't want to have anything that is necessary to bring it into existence. It should just happen by itself. So it's going to be all the operators because you don't constrain them. So every possible matching between bit patterns that define a neighborhood where the bit pattern fits is going to lead to something else. Now, under which conditions do we get regularity, something predictable, where all the different branches cancel each other out and you get a merging of branches again, where basically different trajectories lead to the same outcome. This happens, for instance, when you look at particles. Particles are the set of operators that are self-replicating, that are reproducing their own neighborhood, but sometimes at a slightly different position. And the different position is defined by projecting the neighborhood relative to the other neighborhoods in a consistent way. So in some sense, you will get some operators that are periodic, sequences of operators that lead to the self-replication, and that by self-replicating themselves create metric spaces, so which they can crawl, right? And so spaces are created by these particle-like operators. And only in these regular spaces where you have particle-like operators, or maybe there's some other dynamics which are able to do this too, but this is a primary candidate, you will have structure that is predictable, that is information preserving. And not all of the information is preserved in this way. For instance, you do not know in the double slit experiment which slit the photon is going to go through, because there's not enough information to constrain it. But you know that when you take many of these particles, the statistics over which they will hit the screen. And this is what you can exploit as an agent to predict the future. And in order to exploit it, you have to be classical. You have to be able to come to a deterministic model that allows you to predict the future of the universe from its past, and also your own future from your past, so you can compute. Otherwise, you couldn't. Right? So you will necessarily need to run on a classical subset of the indeterministic Turing machine that is the universe, which will look to you like classical observer in quantum mechanics. And it's an important insight that the collapse of the wave function is not a particular event in the universe itself. It has something to do with your own epistemology. It's the point in your past beyond which you cannot pretend that the universe is classical. Right? So you are creating a classical bubble in your own mind, in your own observations, to make the universe predictable. And this measurement is the point which you cannot pretend that is the case.
Joscha, you're blowing up my mind here in all kinds of biblical and cosmological and quantum mechanical kinds of ways. But I know I promised I'll let you go because 10 or 15 minutes before your next appointment. So let's just wrap it up quickly here with two last questions. Mm-hmm. First of all, what's the best place for other people to find more about you and your work?
At the moment, I suspect that one of the best places are the YouTube interviews, like the one that you just did. In the meantime, I do hope that I get around to write a book at some point. I use Twitter as an online notebook, which is mostly throwaway. So when I have insights that I think are okay to write down, I just write them down in this notebook. And it's a very interactive thing, because no matter how obscure the idea is, there will be a handful of people which get it and respond to it. Or others which ask for clarifications, which also helps. So for me, this is the way to link into an emergent global consciousness that emerges on social media and that is beginning to form. It's a very exciting development, even though it's frustrating and strenuous.
So you're plugging into the hive mind while still keeping your autonomy to a certain degree.
Yes.
Brilliant. Okay, so we covered so much ground again today, but the unexpected part for me was the biblical end of thing. The cosmology I would have expected, but the biblical cosmology and even some theology, wow, that part really blew my mind. So I don't know what you've been reading lately, or the Bible and going so deep.
No, it's mostly that I things that I read as a child, like the Bible, come back. And
why do you think are they bubbling now?
It's largely the insight that the people who wrote these things and the people who deployed religion were rational. I think that starting out with rereading and reconsidering Aquinas, I noticed that the interpretation of the philosophy of Aquinas is often spelled out in such a way that it makes no sense to our atheist and post-Enlightenment education. But there is a way in which these things made sense because they worked. So under the assumption that the people who wrote this and who built this were rational and discovered epistemology, which means you cannot put confidence into things in the absence of evidence, and you cannot exclude possibilities if you have not excluded the possibility of them being true. But this is not hard to infer. If you assume that people had proper epistemology when they did this, when they wrote these stories, and many of our ancestors probably did, what is the implication? And suddenly you notice when you apply this filter that these stories reveal hidden content. And it could be that this content is a projection of mine. So I have no certainty that this is the correct intention of Genesis 1 to give us the theory of the emergence of cognition in the mind of an infant. But it made sense, right? It makes sense that you would give a primer to people who tell them how cognition actually works. And none of the things that I said about Genesis 1 requires modern neuroscience or AI to discover them. What it discovers is to unsee the interpretation of Christianity. Once you're able to unsee the story and ignore the story, this a philosophical interpretation that can be derived by observing infants growing up and doing introspection and meditation, tools that were certainly available to the people who wrote that story thousands of years ago. This is an interesting consideration, that this was an insight that was encoded in a library that we give children to the next generation, and that is still there to be discovered.
Absolutely. I think that's one of the most lasting, time-tested powers of story, the fact that different people can see and unsee different parts and discover and rediscover those parts and kind of put or reframe or reload the vehicle with a new relevant meaning, if you will, or interpretation that kind of updates and upgrades it in so many ways, the carrier. But I just wonder, what would that say about the best way of how we can wrap up our conversation? Should we be something about story? Should it be something about AI? Should it be something about cosmology or cognition or consciousness or intelligence? I don't know. Help me out.
I don't leave that to the next conversation. I think this open-endedness is a very good way to end our conversation.
All right. So, but what that means then is that we would have part 3 coming at some point in the future, and I certainly would be up for that.
Sure. I enjoyed this conversation very much. Thank you, Nicola. That was fun to discuss, and I wish you a wonderful rest of the day.
Joscha Bach, thank you so much for being with us, and the pleasure was entirely mine. It's always a treat to have a conversation with you. It's always a pleasure. If you guys enjoy this show, you can help me make it better in a couple of ways. You can go and write a review on iTunes, or you can simply make a donation.